Okay, we are now good to go. ठीक है जी, now we are good to go for today's another session of learning. And yes, today is going to be a little different because what I have done today is not just technology. I have also thought of adding few of my own experiences that I have gained, and I would love to hear from you about the experience that you have in the life. And this particular webinar or the interaction that we are doing on Saturdays uh, is my personal belief that if we have people who are from the technology field and who are discussing with each other about the technologies, definitely the future world is going to be a better place. So we do have Kamalji ji today. So Kamalji ji, just to begin with, I would just request you to kindly unmute yourself and just introduce yourself, the kind of the experience you have. You have got a great experience, and it will be really great to discuss with you all the applications for today.
Thank you, Vatisa. Actually, sir, uh, I have basically, if you say, I'm basically a scientist.
Mm-hmm.
I'm basically a chemist, chemistry. I did my master's and PhD.
Mm-hmm.
Later on, I moved into the field of ecology and environment because at that time there was no specialization for ecology and environment.
Mm-hmm.
And those of us who did chemistry, we were thrown into that field because there was a new field.
Mm-hmm.
From there, sir, I migrated it into various industries for environment studies, oil, stone crushers,
Yeah.
pulp and paper, glass, cement, you name it. I have monitored that mill. So
Wonderful.
when I have gone there, then I have seen the process also. So I have seen the process from 1991 to 2027 almost now,
Oh,
26th of the year. So
wow.
I have seen how things have moved, how things have been different. And then, of course, automation has played a role. But then this is only either those Honeywell guys or TCS guys who are doing the job.
Uh-huh.
At any other level, uh, maybe one or two smaller, but people like you are now, providing services equivalent, if not better, than those Honeywell or TCS guys. Because I have
Yeah.
seen them working, and I have seen them sort of fuming and frustrating on many things.
I understand that, sir. See, this is a trajectory of industry, how it moves. The companies like Honeywell, companies like Rockwell, even Siemens, these are pioneers. These are the pioneers. These are the people who actually thought out of the box at that point of time. So they actually created such a big companies, and then those big companies created so beautiful products which are actually available in the market. What happens is, it's again, as we discussed earlier, it's always the final delivery boy or the final person who is actually delivering the services to the end user or to the client actually makes a difference. Honeywell products are beautiful, Siemens products are beautiful. I don't see any problems with any of the products. All are good. The challenges that I have seen in my experience is the kind of the service. Either they directly give it, or either they give it through their partners or anybody locally over there. That's a big difference. So in some areas, you will find Honeywell doing perfectly good, perfectly well. And in some areas, they might be not very good, not at par with the requirement of the end user. And I know I have seen, I got into the business basically on this thing because even I worked with these companies, and even I was also getting frustrated at a lot of areas where I saw that a value add can be done, but few of the partners or the few of the company individuals were also not keen looking at the client, and in fact they were looking at their own end because they had some products which were a monopoly. So as you know, it's a human mind. When you have a monopoly, so you actually lose the commitment to serve that particular segment because that was a monopoly, and within few years that monopoly goes off and somebody else comes into the picture, and then you automatically lose that. So that's the way the big companies move, and that's a difference I've seen. Good to great companies. So that is what we have seen. And automation will always be, I would say, it will be piggy riding on the concept. So the people like you who are already into the industry, so automation is not going to work on its own. It's going to work with people like you who actually are in the industry, who need something different or who need something which can be optimized or improved or something, and the automation will follow you. That is why the people like us or the companies like us is actually working and speaking to our end users. We are providing all this one effort today is also in the same segment, that we want that information, the knowledge should be shared with everyone. Because once that knowledge starts to trickle down to the last mile, automatically the problems which are being faced by the industry will automatically go away. Today, you will not hear that we are facing the problems of products from Honeywell in, say, a residential segment or a commercial segment, because the democratization of that particular product has happened. So there is no monopoly of Honeywell or there is no monopoly of any other company in the commercial space or the residential space. Definitely in the industrial space, still the monopoly is there. The reason being is we are responsible for that. And industry, the losses are very high. So people do not try to go for anything new which is coming up. For your information, I'm just sharing it with you, although nobody else knows it. I have also started to try out the Python language for the PLC programming. So
That's good.
yeah. So earlier, the PLC programming is a forte of the individuals. Individual means if you are a PLC programmer for Siemens hardware, you need to have a software primarily from Siemens.
Siemens.
Okay. You want to work on Honeywell hardware, you need a software from Honeywell and the training from Honeywell to use it and all that stuff. But nowadays, we have the PLCs, which are actually open-ended PLCs. Now we can use a standard knowledge of my Python. Or if I have a person who knows about the Python, we have got hundreds and thousands of the people who
Many,
actually know Python. We can take their help to program those hardware. So slowly you will find in the future all these monopoly softwares are also going off. Even some hardware will also go off, and it will be going the way mobile communication has gone today. Most of the mobiles are available off the shelf. So in the future, the PLCs are also going to be off the shelf. The real money that the people are going to make in is the people who are able to provide the services. So the people who are actually into the industrial automation services, they are going to make a killing of, because the end user will be asking for the services and the services will be paid for. Currently, what is happening is, since the hardware is being sold by the big companies, they have a monopoly. So integrators are not able to make good money. So a person like me, I have to add my services into the cost of the hardware to sell a Siemens hardware. Okay. But in future, when the democratization happens, you will find the people like me who have got a good experience in programming of the PLCs, putting a system in line, they will be better sought after than these companies. These companies will remain as hardware companies only. So that is what is going to happen in the future. So we had a great discussion. So what I'm going to do is I'm going to start with my basic presentation that we have. And once that is done, then we will be moving further with that. Just a minute. So I'm going to share my screen with you for today. So today we have a plan, which is a weekly plan, which call it Elevate with Advance. So Advance Engine is a company which is actually here to elevate the knowledge, elevate the people who are actually our partners. The partners means we don't consider anybody as our customers. We consider everyone as our partners. Even our vendors are also our partners. Even our customers are also our partners. Our people who are looking after our well-being, who are our mentors, they are also our partners. So why I say partner is that this is a very respectable thing, that we are partners in each other's growth, and we actually help each other to grow by giving feedbacks, by using the products, by paying us for the services, by providing us the products, by providing us the know-how. Everything is actually over there. So that's why we want to elevate everyone. So the first step that we want to do is we want to empower the engineers. So anybody who is buying our hardware or software, we want to empower them so that they can use it on their own, so that they can select it on their own. Sometimes what happens is the engineers join a company, but they do not have enough experience. So they learn it on the way. So they have to burn their hands. हाथ जलाने पड़ते हैं जमीन पर रह के काम करने में, and then it takes time. So what we are trying to do over here is we are trying to help those engineers to come up and learn from us, and so that they can implement those technology in their field on their own. We also are trying to build industry excellence. This is very, very important that industry, even today, as you said, is not very, very, I would say, democratically placed. It's still monopolized in a lot of areas. So what they happen is people do not move towards the excellence. Here we are trying that the companies, manufacturers who are using industrial automation should be moving towards the excellence. And third, but not the least, is we are also trying to create the future leaders, because engineers, once they start growing in the field, they actually stick to only the technologies. Technologies stay up to you up to some time, but it is the real wealth that you create along with the people, and you actually grow in the stature. That is what is going to happen. So we are helping the engineers who are actually working to create or become the future leaders also in their own organizations. This is also one of the efforts that we are trying to do over here. Now, what we are going to do or cover over here is industrial automation and instrumentation fundamentals, so that the industry and engineering gap should be bridged. So there should not be a big difference in both of them. We are also trying to simplify the concepts, because sometimes what happens is people are really worried about the concept they did not know, and they go and read the manuals and so many other things, but then they need somebody to help them to grasp those concepts. So we are here to help them. We are also trying to help the industries to improve on their productivity and efficiency. So this webinar is not just going to help me. Definitely, it is going to help you guys also. So if you learn something from here and you implement that in your industry, it's definitely going to improve on your productivity and efficiency. I'm also trying to create very, very technically strong and conscious engineers. This I've found in my last 30 years of experience, that engineers are good. They know technologies, but they are not conscious about that. They do not have a purpose of their life. So they do have, like, I want to earn this much of money, I want to do this, I want to do that, and all those things, but they don't have a purpose. So unless we have a bigger purpose in our life, we will not be able to be successful. We will not be able to peaceful. That is what I'm looking at. So we should be very, very technically strong, and we are going to help the people more conscious engineers. Then I also want to build a professional community focused on growth and contribution. This is my biggest takeaway from these webinars, is that I want you guys to join me. Let's create a community where we keep on helping each other. We keep on discussing the kind of the challenges that we keep on finding the solutions for each other, so that we should never feel alone or left out. I have seen boys and girls who have actually joined some organization, but then they are left alone. Nobody is there to help them out. And it's a very, very difficult field out there. So this is the purpose of this particular thing, this community. So with your permission, I want you to give me a few minutes to introduce myself. My name is Manmeet Singh Bhatti. You can always Google me. My name, I'm one of the kind in the whole world. And so I have not found any other Manmeet Singh Bhatti. I have found a lot of Manmeet Singh, but there is no Manmeet Singh Bhatti. So if you find somebody, please connect me with him also. Then I am a BTech in Instrumentation and Control from a college called REC Jalandhar. Nowadays, it is also known as NIT Jalandhar. So I'm alumni of one of the good colleges in the country. I have got almost 30 plus years of experience. I passed out in 96. So this is 2026. So it's almost 30 years. This year, I'm going to complete 30 years of experience. I work with the companies like Force Marshall, Honeywell, and Rockwell Automation. All these three companies are the pioneer company in the field of instrumentation and automation. I learned a lot from these companies. I really love these companies. Their products are really marvelous. And they actually changed me from a young boy to a professional. So this is the thanks, and I'm thankful to all of my mentors who have worked with me, who have helped me in this organization to grow. After that, in 2011, I founded a company by the name of Advanced Engineers India Private Limited. This is a company purely into system integration of process instrumentation and automation, and top 10 system integrators in the country. I also founded a training school by the name of Industrial Automation Hub. So this webinar is part of that particular initiative. I also created a company by the name of FarmFresh for You and Blaze Elder Care. These are my other ventures that I have started. I'm a author also. My book Job Hunting Reimagined is an Amazon bestseller. You can just find it out. Actually has helped hundreds of students to actually get their first job. Just go and read that book. I can assure you, you will be getting your first break and be part of that committee. I'm there to help you out. I'm also a TEDx speaker. I'm a career coach and a farmer by heart. This is about me. This is what I have done in last 30 years. Moving further, what I'm trying to create this community, the vision of this community is building better engineers and better industries. We just don't want that people should not understand the process. We want that they should be improving on a daily basis. So we are trying to build better engineers and better industries. We want the engineers to continuously upgrade themselves. What happens is people get a degree, and once they get a degree, and then after that, they don't learn on anything. This is the biggest mistake. So I want the engineers to continuously upgrade themselves. We also want that industries should get technically capable professionals. So what happens is the industries actually get the people in bulk from the colleges, from the industry, they hire them. But sometimes that crowd is not technically capable. So we are trying to help that industries get their technically capable professionals. And if you are working in the industry, you try to learn from us and become technically capable so that you add value to your industry. Then knowledge sharing becomes a culture. This is one of the biggest things that humans should always be proud of, that we should be sharing our knowledge. But in industrial automation community, what happens? What happens is people are afraid of sharing their knowledge. Knowledge shared actually grows, and knowledge, if you are not sharing it, actually goes away. So my advice to everyone in this webinar is that please share your knowledge, please share your success. Problem is that we feel that somebody will copy my concept. There is nothing called copy. If somebody, everything is available in this world. If you try to find out, dig enough, you will be able to find those treasures. You don't have to cover those treasures. You have to share it. Once you start sharing, you will see the abundance coming back to you. So make sure that you are sharing your knowledge with everyone. Growth happens collectively. No individual can grow on its own. So I'm trying to help the engineers. I'm trying to help my customers to learn industrial automation and to implement their projects on their own. And sometimes people tell me that this is the job that you do. So if you train your customers, if you train the engineers to do the job on their own, why are they going to give you the services? Understand that. If you guys grow, I'm very sure you are going to ask for my services future again and again, because I'm the person who has got that 30 plus years of experience. Adding that experience today is going to be difficult, and the time is the money, guys. So if you understand how the things work, you will definitely come back to me. That's number one. Second thing is, I truly believe, sincerely believe that if I give out to you guys, definitely you in some way are going to give it back to me. So this is what happens. This is what I truly believe, that growth happens collectively. I individually can never grow. If you guys grow, I can always grow. And technology is used responsibly and efficiently. This is one of the biggest things that we have lost now. That as individuals, we don't care about, we misuse the technologies. We should make sure that we use the technology as per the need, responsibly and efficiently. Let's not create those technologies which are not good for the mankind. They are destructive in nature. No, let's not do that. Let's go for creation. Let's go for better life. That is what we should be working on this. Now, I have created this conscious engineer approach. It's very important that you learn that If you want to be this community, you have to be a conscious engineer. Now, conscious engineer has got this 7 properties. First is the conscious engineer always keeps on learning continuously. At whatever age you are, at wherever you are, you should never be bothered about learning. Keep on learning. Anything new coming your way, please keep on learning. Next is conscious engineers never think on salary. They always think beyond salary, the kind of the value they add. As soon as they come out of that field, that they are not here to go for salaries, they are going to go for a kill. Because salary is just a small component of your life. As soon as you start thinking beyond salaries, the salaries become immaterial. You will never be even bothered about that salary. You will be getting that much of abundance. You will never even count your salaries. Conscious engineers also value discipline and consistency because anything that brings results is called discipline, and second is consistency. Even 1% improvement every day is going to create a high level of improvement for you. Keep on doing, keep on putting that discipline in your life, keep on doing something which you really love, you will really want to grow. Keep on doing it, you will definitely see the wonders coming your way. Then we have got another part is the works ethically. What happens in the industry when the people learn, when people start to have unethical practices, it may get you success for few days or few years. But if you keep on working ethically, and the day you retire, you don't have any regrets. You will never have any regrets. You will always love the way you have lived your life. And the day when we leave this earth, we have got only satisfaction, gratitude, and thankfulness. That's it. That is the way we should be working ethically. So conscious engineers also contribute to the society and industry. This is called the giver's gain mindset. People should be giving it to the others. Try to give more to the society. Try to give it to the industry. Try to work on something. I don't say start a charity. Not at all. Don't start a charity. But even if you help other people learn something new, if you help to create something where you are actually using systems which are actually reducing the energy consumption, definitely it's going to help the entire society. Try to keep on doing it. Consciousness also solves problem responsibly. They just don't take any shortcuts. They create a framework where they are actually able to solve responsibly. And they always respect people, systems, and processes. I have seen people who are not very positive in their approach. They do get success, but they do not get success for a very long time. A conscious engineer who is part of my community should always respect people, should always respect the systems, and should always respect the processes. That is the only way we grow. Okay. If there are any questions, just let me know. I can actually explain all the pointers over here. Do we have any questions? Okay. So if you have any questions, you can just ask in the chat box. I will just see that and I can respond to that on this. Now, these are 6 core values I want that you should be always be focused on. First is the continuous learning. So industry evolves every day. Learning should never stop. Should please follow on this. Practical knowledge. Always the real world applications matter more than theory. So people try to learn theory, but if you learn the practical applications, you will be getting a better value. Integrity and trust. Professional credibility is built through honesty and commitment only. There is no shortcut for this. You may get a success by going for a shortcuts or something like that for few years, but your whole life will never be dependent on this. Your whole life will be dependent only on integrity and trust. Grow through contribution. Always help the other people to grow. When you keep making efforts that other people will grow, the nature automatically helps you to grow. It is not going to let you stay behind. It will always there. Try to help other people to grow. Then we should have a positive professional culture. Always encouraged. Go for collaboration, respect, and collective environment. If you need something, ask for help. If somebody is asking for help, help him or her. Once the collaboration happens, you will see the growth. People talk about competition. Focus on collaboration. Competition will keep on thinking how you guys are getting successful. That's the beauty of the life. Discipline and consistency is always there. Any small, consistent effort that you do is going to bring you massive results in the future. So these are the 6 core values: continuous learning, practical knowledge, integrity and trust, growth through contribution, positive professional culture, and discipline and consistency is something that you should be looking forward. These are the core values of our community. Now, let's discuss why the industrial automation matters. So, make a note of all these 7 pointers. Anybody in the industry cannot deny that they want to increase the productivity. Every day we have the fight that we want to improve the productivity. We also want to improve the quality. Every day I want my product to be best of the quality. I want to improve on it. I also want to reduce on the downtime. I want to save on the energy. Now, energy can be anything: electricity, fuel, compressed air, steam, manpower, raw material. You talk of anything, it's energy. Everyone wants to save energy. I want to improve on the safety. This is a very important thing which has come up in the last few years. People are now very clear about the safety. They want the manufacturing places to be safe. They want to reduce the operational errors, any kind of mistakes that happen in the operations. They want to reduce on that. And they also want to start that data-driven decision making. Earlier, they had manual processes. Now we have got IoT, automation. So these are the 7 pointers nobody in the manufacturing can deny it. I would suggest, if in your company you are there, just pick one. Just pick one pointer from here and think about in the next week what value add you can do in your industry by using any of the 1 pointers over here. Okay? Moving further, I need a commitment from you guys. First is, I want that you should be attending sessions regularly, because the sessions are going to come up on a regular basis. Please attend them. Stay curious and ask questions. This is very important. What happens is people get into the session, but they don't ask questions. If they don't learn anything, they have the doubts, and then they just go ahead. This session is not for judging you guys. This session is for knowledge sharing. So if you ask questions, maybe I will be able to answer you. Maybe somebody in the community will be able to answer you, but that question will be solved, that problem will be solved. But if you don't ask, nobody will come to know that you have some questions. Practice what is taught. So whatever I have shared over here, what I'm going to share, please make sure that you practice on this. It's very important. Respect fellow learners. Let's not spam anybody. Let's not trouble anybody. Let's not judge anybody. If somebody is asking some questions, let's follow that. Those questions we should be also noting down. Try to help them to learn those concepts. We should respect the fellow learners. Share knowledge with the others. It's very important that if you have got a case study, if you have got some application that you want which is relevant to that particular topic of discussion, please share. Definitely. Maintain professionalism. Don't trouble anybody. Don't get personal with anybody. Please maintain the professionalism and keep learning consistently. These are the small commitments that I want from you. Please give in the chat box that you are committed. Just give in the chat box that yes, you are committed. This will help me to understand that you guys are committed. Great. So build the skills, build the character, build the future. So first of all, why it is important is technology changes very fast. If you don't build the skills, you will be left behind. Skills create opportunities. So if you know something, only then. We have a noise of AI coming up, taking your jobs and all that stuff. The people who are having the skills, they are not bothered. People who are not having the skills, or people are having rudimentary skills, they are bothered that AI will take away the jobs. Discipline is very important. Focus on discipline. That is only the way you are going to create success. In spite of your having skills, until you don't have a discipline in implementation, you will never be able to succeed. And contribution. Until unless you don't contribute, you will never be able to create a legacy. People will remember you because of your contribution. People will never remember you of your skills or discipline. Whatever you have contributed to the society, it will be considered. So we are now done with the basic introduction. We are now going to move to the topic of the day, which is called RTD and thermocouples. So I've got two different presentations of technically things. So let me know which one you want to take first, RTD or thermocouples. You can put it in the chat box also. What topic
Actually,
you want me to take it up?
I would like to go for thermocouples. They are
Okay.
one trouble point in the industry where I worked in.
Wonderful, sir. So we will start with the thermocouple then. And give me a minute. I will just start my presentation on thermocouple also. Okay, so what I'm going to do is I'm going to share the thermocouple. So can you see my slide, please?
Yes, please.
Okay. So what I've done is I've kept it very, very simple. I've not created very big presentation. I've kept it just 5-10 slides. So we can understand what is the industrial thermocouple, how it works, what are the design criteria for this. This is what I'm trying to do over here. So one thing that in instrumentation we always say is, if you cannot measure it, you cannot control it. It's very, very simple. So any kind of the process that we have measurements. So here we are going to talk about is the process temperature. Now this process temperature is a product, there is a measurement which is very, very critical for any kind of industry. You can have furnaces, you can have oil and gas refineries, you can have any kind of heating areas, any kind of HVAC applications. You need to measure those temperatures. And thermocouple is one of the undisputed workhorse. So it's not bothered about where it is being installed. You can find thermocouple in basic furnaces. You can find thermocouple in the steam applications. You can find it in some heating applications. You will find it anywhere. So what it does is that particular heating energy which is coming up from the process, it turns it into the micro voltage signal. So thermocouple beauty is that why it is being used in the industry to the maximum is that it has no requirement of a power supply. So actually the millivolt comes without a power supply. All other sensors need some kind of a power for something to come out. But in the case of thermocouple, not at all. Thermocouple directly gives you a micro voltage signal. This is the beauty of the thermocouple. Now, how it works is basically, don't get into the formula part right now because formula is something meant for the calculations part. There is a principle by the name of Seebeck. So Seebeck principle, what it does it says that if you have got two dissimilar metals, so two dissimilar metal means metal number A and metal B, both can be different ones. And if these two dissimilar metals are joined, okay, are joined at one end, which is called a hot end. On the left side, you will see is a hot end, and on the right side, it's a cold reference junction or a reference junction. It's cold because temperature mostly we are going in for the hot temperature. So that is what we have. So whenever you have one joint in a hot and one joint in the cold, actually there is going to be a millivolt in the loop. This is a physical phenomena which is called a Seebeck effect. Very simple. So there is no need of putting any power over here. As soon as you put this hot junction into the hot area and temperature rises, automatically the voltage will start moving in the sensor. Very simple. There is a millivolt. So it's a very small voltage. It's not very high voltage. This is what is going to be there. So this is what we have. So formula is there. What kind of the voltage it is going to come up. What I'm going to do is don't focus on the formula right now. Just understand how it works. Once you understand that how it works, the formula will become easier. I'm sure if you are an engineering graduate, you must be knowing this kind of formulas, but I will be sharing it in separate I will be giving you a write-up also how to calculate on that. Currently, just focus on how it works. So it's a very simple one. On one side, it has got a hot junction, and other side, it's a cold junction or a reference junction. And whenever there is a change in the temperature, automatically there is a millivolt moving. Is it clear? If there is any question, you can just ask on that, or you can put in the chat box in case you face any questions or you want me to clear something. Hope it is clear.
Yes, please. Yes.
It's a very simple application. Now, moving further on this, I want to show you the construction, how it works. So we have seen the metal is very simple metal. That is the way it is going to work. But that metal needs to be protected, because when the sensor is installed into the field, there are too much of heat coming out, there is too much of pressure coming out, there is too much of vibration coming on it. So we need to protect that sensor. So if you see the complete breakdown of this entire thing, on the sensing number 1 is called the hot junction. Okay, this is the point where it is going. So actual generation of your voltage will start from here when the temperature goes away. Okay, that is there. Second point is called the insulation. So what we have done is, because it's a metal over here, it may cause shorting. So the shorting may happen. So what we do is, putting for insulation, we put magnesium oxide powder. So there is a tube, or tube ke andar we put a thermocouple, and from the thermocouple it is having the insulation of MgO. So that is always put in over there. And after this MgO, you will find the sheath. So sheath is nothing, it's a SS316 or whatever the metal compatibility of the process is there. It can be Inconel also, it can be titanium tantalum also, based on that. So that's a sheath. Sheath, nothing, it's a tube of that particular thing, and which can handle that pressure, which can handle that vibration, and through which the sensor goes, and on which we actually put in magnesium oxide, and it's actually filled to the brim, and it's gone to the end. Then the end you will find is aluminum head, or the point number 4, which is called a connection head. So your thermocouple wires goes over there and they get connected. Very simple design, not a complicated design, but this is the actual engineering. So thermocouple, we have got a temperature. This temperature sensor is actually outside in the field where it actually measures that, and based on that you get an out. This is the way it works. But selection of a sensor is very, very important, that you actually create what kind of the sheath is there. Sheath is very important because in the process, you are not measuring just temperature. The temperature is one parameter which is for measurement, but you might be having lots and lots of corrosive acids coming in. You might be having lots and lots of vibration coming in. So that sheath has to be designed based on the process conditions. Okay? So that is the way it works. So this is the way it works. You must have seen this. I have given you a breakup on this. Now, these are the 3 charts where you will find that how the response speed is going to be based on the design part. So if you see the first part, where we see that is the sensor is actually grounded. Grounded means sensor is actually touching the body. So when on the left side, first left column, as you see, the sensor is showing grounded. Grounded means it's touching the body. So the heat, whenever it is coming into the body, as soon as there, the response speed is very fine. Okay, it's very, very high. So as soon as the temperature comes, it touches the sheath, automatically you will find a temperature coming. So what will happen is the speed of response is very high, but the problem is also there. Since it is touching the sheath, if there is a problem of some kind of a noise coming in the ground loop, because the product is grounded, but there is a grounding is not proper, or there is some noise coming in that loop from the nearby. So what is going to happen is the isolation breaks. You will not be able to get proper temperature, and you must have seen the temperature sensors fluctuating too high in sometimes on the SCADA. So the grounded one should be used primarily on a good applications. Good application means the application in the process where you can have a better grounding and all those things, you can just use that. That is the way. It's a very prone to the installation mistakes. So you should be installing it in a proper way. The grounding should be proper. It should be an instrumentation grounding, not an electrical grounding. No noising should be there. Shielding should be properly grounded. It's there. But yes, it's one of the fastest moving thermocouples that can give you an output. Second is called the ungrounded. And you can see the picture from here. The junction is actually not touching the outer section of the walls or the sheath. It's little bit inside. So what happens is it takes some time for the temperature to reach. You will find the response is not very fast. So this central column you will find is the speed is little lesser, but it's away from the grounding. So what is happening is any kind of the noise which is coming in the ground loop, it's immune for that. So this kind of the thermocouple should be used where you have got a high level of electrical noises. If you have got very big motors coming in the picture, you have got very big VFDs over there, thermocouple design should be ungrounded. We should not go for a grounded one, but we should go for an ungrounded one. Because when you have got so much of heavy motors, heavy loads running around, it's very difficult to find a perfect ground or perfect earth. There is a possibility of you are using the same cable, you are using same. So there is lots and lots of noise coming up. So I would say whenever you are installing it in a very noisy environment where you have got VFDs, you have got big capacitor banks, we have got big motors, make sure that you go for ungrounded one. The third, as it shows, is called exposed one. Means the sensor is exposed directly to the media. Here you will see the response is very fast, but we do not have any kind of isolation here. So there is no isolation here. So it's susceptible to any kind of pressure changes, high level of temperature changes, wind changes and all that stuff. So it has to be used on very, very clean application. Clean application means we can go to HVACs. In HVACs, we have got mostly coming air, a little bit of moisture, but it's not very high pressure. So HVAC can be. So you will find the sensors which are used in HVAC are mostly exposed one, or they have like PVC sheath and all that stuff. So that is there. So it's up to you what kind of the application you have. You can actually put in the thermocouples as per the need. If you have any questions, just let me know. I can explain on that also.
But you have just one word on because there is a lot of halagulla on calibration of thermocouples.
Yeah, I will come to that, sir. I will come to that, sir. I will come to that. I hope this one is clear up to grounding, ungrounding, and that.
Yes, definitely. Thank you.
Wonderful, wonderful. So till now, I have only covered the basic part. Basic part is how the construction of thermocouple is there, why we use grounded or ungrounded. I'm moving further the types of the thermocouple now. Now, if you come over here, we have got different types of the thermocouple. So if you see in the center, we have got a K. It's the king of all the thermocouple. This is the mostly it is being used. But thermocouple, why they are called K, why they are called T, why are they called S, R, B, J, and these are there. There is a reason behind that is all these are classifications. Now, if you go for a T-type thermocouple, it's copper and constantan. So these are the two alloys which are being metals or alloys being used, and the range is actually coming to minus 250 degree to 350 degrees. Okay. So if you have got any cryogenic applications, freezing applications and all that, we can go move into the type T type of sensors. Okay. So that is what, so it defined on the ranges first. So that is there. Second is we have got a type K type where we use chromel and alumel. Now this is the most used in the industry because it has got a range starting from minus 200 degree to 1260 degree. So what's happening is, if you go into a freezing application, normally we have like minus 40 degree, minus 50 degree, thermocouple works. We have got hot treatment application, 800 degree, 900 degree, 950 degree, we still have the same. So from minus 200 to 1260, it actually caters to almost 70 to 80% of the industry. So 70 to 80% of the industry is being catered. So mostly you will find the people using K type in the industry. Okay. Now moving further to other types, if you talk of like S, R, and B, what happens is these are basically for your heavy furnace applications. So they are using temperatures up to 1700-degree temperatures. So where you can get the molten ones. So that's why we are using platinum and rhodium applications for that. These are very noble metals and these are very costly also. So the applications where the temperatures may run up to 1700-degree, these kind of the classification of the thermocouples are being used. Then we have got another which is called type J. Type J is also there, where we get a temperature of 0 to 760-degree temperatures. Now what happens is type J is little cheaper kind of a thermocouple that people call it. So you will find the industry using either J-type thermocouple or either K-type thermocouple. So that is the way it moves. But what happens is J-type is having a ferrous component, like iron component here. So the biggest problem over here is the durability of the thermocouple, because if you find some kind of moisture coming in the line picture, you will find that particular connection of iron getting corroded. So that corrosion happens very fast because of that. So be very clear on that, what you want to use, where you want to use. So if you want to use a K-type thermocouple, which is mostly in the industry, you can definitely use that. But lots and lots of the industry are also using J-type. So J and K are mostly used in the industry, but you can also go for rhodium base and you can also go for the type T also if you're going in for a very high level of cryogenic application. So these are the main, make a note of this. You can understand that this is the reason that people are using these kind of the thermocouples over here. Now, I will be answering your question little later, but before that, I want to show you how thermowells are to be used along with the thermocouple. So if you look at the picture, on the top of side is the thermocouple, okay? But on the bottom, if and the cross section of the pipe, you will find is we have got a machined bar. So there is a rod of SS316, 304 based on that, and then we have machined it, and then we have actually entered, we have inserted the thermocouple. Why we have done it is this thermocouple may or may not need removal from the process. Like you said rightly that we may have to calibrate it. If I have to calibrate a thermocouple, I have to bring it out and then calibrate into a known temperature chamber. So I have to bring it over there. If I don't bring it over there, I will not be able to calibrate it. So sometimes we have to remove that sensors. Just to do that, we have got these kind of thermowells, which are clearly solid bar stock, machined, and they are always integrated onto the pipeline. And we insert the thermowell on this thermocouple on the top. So thermowells stay in the pipeline always, and you have a thermocouple removed whenever you want to. So this is the way you can do that. So you don't have to remove the process or you have to isolate the process, you directly take it out. This is the way you have to use. So all the temperature sensors should always be installed with the thermowells. Now, this is one area where people lose a lot. People lose a lot. If you go to the old slide of this, I have shown you that because of the Seebeck effect, there is a temperature difference between a cold junction and a hot junction, and we get a millivolt, right? This is the way we started. Now, most of the temperatures are being measured from the hot junction because we are going for hot temperature. Very few we go for a lower temperature, but mostly it's the hot temperature. So we are worried about the temperature accuracy coming from hot. What we miss is basically the cold junction. Now, cold junction, people assume that if my cold junction is outside the process, it will stay that way. But that is not the case. cold junction temperature also rises or reduces. It also plays its role in the millivolt coming. Imagine you have got a thermocouple which is put into a furnace where it is going to measure 200-degree temperature, and your cold junction is outside where the ambient temperature was actually 45 degree, but due to the heat, that 45 has gone to 50. So your cold junction has actually increased by 5 degrees. Okay, so your millivolt will be error, and you will be giving me that my temperature measurement is not accurate. Actually, it's accurate, but you have not gone for a cold junction compensation. So I show you how it works. Now, this is the way it works. We are giving a millivolt out of this, and this is going on. What happens is, whenever, because that cold junction is connected to my measurement signal, like it can be connected to my controller, it can be connected to my PLCs and all that stuff. So what happens is, my PLC or the input card of my controller actually measures the actual temperature over there. Okay, so it actually measures the cold junction temperature. What is the actual temperature? The temperature might be 35 degrees, it might be 20 degrees, it might be 45 degrees, depending on installation. And then it actually applies the offset to it. You getting my point? Then it applies the offset to it. What happens is, when you measure the cold junction temperature, you are able to compensate for that difference, and you are able to get that. If you don't go for the cold junction, you will never be able to get an accuracy. You will never be. This is the way the accuracy of the thermocouple is actually measured. Lot of people miss out on the cold junction compensation, and they actually get the errors in this. Okay. Second error that comes is this second mistake that we have. If you see the picture, what happens is, people install the thermocouple in the thermowell, and the two wires are coming out of it. Now, these two wires actually have to go to the cold junction for the measurement, either into a PLC or any controller. So if you see K-type sensor, we have got chromal and aluminum coming up. Now, after it comes out of that particular sensor, what we do is, we put a standard copper wire, okay? Standard 2-core shielded and all that stuff. We use that copper wire, and now we take that copper wire back to my PLC. Now, what is happening over here is, you have created another junction for the thermocouple over here. So we have got one junction which is a hot junction, and on the cold junction, again you have added copper, and that copper is again getting added to the PLC, and in the PLC you are measuring it on the thermocouple side. So the properties of the metal that are being used for propagating that signal to the PLCs are also very, very important. So we should never use a normal copper wire to be wired to the PLC from the thermocouple. Always make sure that you have got a same set of thermocouple wire. So the same alloy or same cable metal should be used, and it should be going directly to the PLCs. That is the correct way. Otherwise, what is going to happen is, it's going to create another ghost thermowell, and it is going to give you an output of this. Okay. Now, you talk about. Now, what I'm going to do is, I'm going to come back on this. This I will take in a little later. Now, coming to your question of calibration of this, sir. You said, how to calibrate the sensors. Very, very easy, sir. If a thermocouple has been properly designed, and there you will never find behavior of drift coming up unless the wire or the chromal or aluminum wire, they are actually being degraded because of any reason. Otherwise, it remains the same. Second thing is, it's very easy to calibrate this thing, bring out the sensor, put it into a hot bath, have a controlled measurement of temperature over there, compare it against another sensor, and you are good to go. Most of the time, there is a very less drift in the thermocouples. But if there is a drift, we can always compensate it outside. Second way is that the best way is that always put a transmitter on the top. So as soon as if you see on the head, on the right side, there are 3 wires, connection head. As soon as these wire of the thermocouple are connected to this head, on the head, we install a transmitter. So what the transmitter does it actually converts your thermocouple input directly into 4 to 20 milliamp. So what we are getting here is, instead of a thermocouple output or a millivolt output, we are directly getting a straight 4 to 20 milliampere output. Now that cable can be a normal cable, copper cable, which can be multi-stranded and sent to the control room, which can be like, say, 500 meters away, 700 meters away. It can be done very, very easily. So this is the way it works. Sir, you hope I have explained how it is going to work, or if you have any questions, you can just ask, or any past experience if you have, you can ask on that.
Actually, that's where I come in, because I understand that calibration probably is not required. But you know, these guys, the standard guys, ISO guys, when they come along, they will always ask for a calibration certificate for this. That's
Yes.
where the problem starts.
So this happens is because industry corrects it itself. As per the IEC norms, any instruments that has ever been manufactured should always be calibrated within 12 months. So every 12 months, every instrument should be calibrated, including pressure gauges. So if you are having pressure gauges in your plant, you are going to calibrate your pressure gauges also against the deadweight tester or master calibrator and all that stuff. So that's a norm. So if there is an auditor coming to you, he or she will always ask for that calibration. I always recommend that for measuring the thermocouple temperatures, have a hot bath. So if you have a need of, like, say, 500 degrees, 700 degree calibration, have a 3-point calibration, calibrate it, put that calibration certificate in your file, and have it ready for the any kind of the auditor who wants to sue that. But always make sure that you do it against the available standards only. NABL standards should be followed. Is it okay, sir? Shall we move further?
Yes, please.
Okay. Now, this is something, what happens is people have not much clarity on the things. Okay, on the SCADA, you see that temperature alarm is active. There could be many, many reasons. First of all, first reason is that your milliampere has gone to 21 milliampere. So we covered milliampere signals in the last week. So 21 milliampere, so it means that the open circuit is there. So your circuit has already burnt out. You have got more higher. So what is happening is thermal cycling snap to hot junction. Now it has gone into the safe shutdown interlock. This is one reason. Second thing is, SCADA temperature is going down, but your process is heating up. It's basically nothing else. It's a reverse polarity. So positive to negative, just switch it over, you'll be able to do it. Now, note over here is North America, the industry, red wire is always considered negative. Most of the industries outside America, they call red is always positive. But in America, it's always negative. They do it in an opposite way. So make sure that if your product is going to America or you are using a product in America, red wire should always be considered negative. It should never be positive. This is one of the areas where people make a mistake. So if you put an opposite, so your temperature will be showing down, but actually it will be going up. That is there. Next is reading is stuck at an ambient temperature halfway down the pipe. You are just getting at that. So what it means is it can be a short circuit. So what happens is some temperature or millivolt is coming, but MQ insulation has failed. So it has gone down. So what happens is wires have touched halfway. So it is not touching the tip. The temperature is not coming from the tip, but it is coming from in between somewhere. So it's holding over there. So it's not going up or down. So it will be this. So these are the 3 major types of the problems coming with the thermocouples that we have already faced. Now, there is also a comparison between that people see that whether I should be using RTD or I should be using thermocouple? I would say you are the best judge of yourself, that what you want, how you want, and where you want to install it. I have found RTDs more accurate, but RTDs also fail a lot. So they work good, they have good response, they have good accuracy, but they fail a lot. On the other hand, we have got thermocouples which have not a very good accuracy as compared to RTDs, but they extremely successful in any kind of vibration, any kind of high thermal jumps, and they are quite rugged. They have got a big range. So that is the way. So it's up to you how you want to install or where you want to install. Normally, what I see is whenever a RTD can fit into the picture, always go for an RTD, because instrumentation means more accuracy. But if you have got an application where you need a rugged sensor, very high profile sensor, which cannot fail, your process is very, very important for that, always go for a thermocouple. So thermocouple can also give you that. So this is the thing that we have in the part of thermocouple, sir. So if you have any questions on the thermocouple part, I can definitely be more than happy to answer on that.
I think you can go ahead as of now.
Okay, that's wonderful, sir. So now my next presentation is on RTD. So ठीक है, थकता नहीं गए तुसी? Or we take it next week?
As you wish, as you wish.
No, sir, I'm available because we have already spent 1 hour. Nobody else has joined, so मैं कह रही कितना करिए? We should wait or we should continue. It's up to you.
Maybe we can do next week, sir.
Okay, we can do next week also, sir.
Maybe a wider audience.
Yeah, people will be coming. See, this is what happens. Sometimes it's a Saturday. Sometimes people will come. Sometimes people will not come. My job is that I will keep on giving that knowledge. It is coming on YouTube. There are a lot of people who are actually watching on YouTube right now. So that's fine with me. And this is what I'm trying to explain to the people, that how it works. And the people who want to improve, they will definitely be joining again and again. So that is there. So thank you for that. And any feedbacks that you want to give on this, sir?
No, I think, somebody who is a learner, or let's say a new entrant to the field, thermocouples, this is the best explanation of thermocouples I have come across in many, many days, because these basic points are never covered in the way you have covered, even in textbooks. So it's very important to grasp the basic points. Thermocouple is something which is used everywhere. You name in the industry, they use it.
Yes.
And then the problem is also with the thermocouple.
Yeah, people don't understand what is thermocouple, first of all. They assume that because people have seen RTDs, so what they assume is that we will insert the thermocouple, we will get the temperature. But they do not understand that how thermocouple behaves. I just share one example for one of my very big customers. Very, very big customer means Fortune 500 companies. Okay, so it's so big. They have got the best of the things. And I visited there, that they were having a problem that our temperatures do not match. Our audit is an issue. Our temperatures do not match. We have got a problem. I said, fine. I just went there and I saw everything, the state-of-art PLC system, state-of-the-art SCADA systems and all that. And still they are doing the manual thing. So they had those handheld temperature measurement devices. They used to go there. Every hour the person was noting those temperatures. And that is the way they were doing the audits. And they were putting those reports for their customers further.
It's 4 o'clock.
So when I saw that, and I said, why it is there? So I said, okay, let's do one thing. You give us a month's time to set all of your things right. Our team will come and analyze this, and they will only give you recommendation. If any hardware is required, we'll let you know. Otherwise, we will try to set everything right. And you will not believe, for full 1 month, my team was there. They were, I think, almost 500 to 600 thermocouples in the plant. This was a big, huge plant. There were only 2 problems. One problem was that the cold junction compensation was not there, number one. Second thing is they had the thermocouple installed, they had the cables installed, but all those cables were actually going through the hot zones. Okay. So there is a thermocouple which is in the furnace, and from there the cable is coming out, and that cable is actually crossing nearby to the other furnaces where it is getting heated and the millivolt is going haywire. Very simple. So what we did was we simply converted those thermocouples, we removed them. We simply put our temperature sensors over transmitters over there, and we created them to 4 to 20 milliamperes. Now they are doing very fine and they are very happy. And in a few cases, we isolated those cables on a normal temperature so that they do not get affected because of the other furnaces temperatures, and they have worked fine. So these were two very simple things which were supposed to be done, but everything was closed by them. So this is the way it has worked. So we learn from customers, we learn from the applications, but yes, you rightly said, thermocouple is one of the areas where people still do not have a knowledge, but it's an immense application. And if they just follow this video, I'm very sure most of the problems will already be solved.
There's another thing to it, these sensors, thermocouples are one part of the sensors.
Yes.
In my field, these sensors have graduated into sensing various gases in
Yes.
the fluid. So,
Yes.
I think, if I'm not wrong, still in India, no one actually manufactures those kind of, sensors.
Yeah.
And if you don't understand thermocouples to start with, you cannot graduate to sensors.
Exactly. Exactly.
I think that is where I am trying to hit actually.
No, I got the point. I got the point. This is one of the biggest challenges that we have seen in the market coming up. That people are not, when you don't understand the principles, you lose out on the application itself. As you said, selection of gases, all detection of the gases, kind of the gases and all that. So this is all physics. And if you don't know the physics, you will never be able to find out a way out of it. So that's what the scientists normally do. That's what the people like you do. But if normal engineers can start understanding the physics, the life will become very, very easy, and they will not face much of a problem. So this is what I think we are trying to do here, is trying to tell the people, follow the physics and the solution will automatically follow you.
Great.
Great, sir. So, sir, we will be winding up the session now. Thank you very much for your time. And my dear audience, if whosoever you are willing, please give us the comments and the feedback if you want. We're here to answer your queries. Thank you and Jai Hind.